Welcome back. We're about to tackle a really huge challenge in modern systems. How do you actually build reliable, multi step processes when you can't just wrap them up in a nice, safe database transaction? Okay, let's dive right into this. So, this right here, this is our starting point. It's a hard and fast rule that basically forces us to throw out the old playbook. In a distributed world, you just can't atomically write to a bunch of different places at once. And that means we have to design our systems with a completely different mindset from the get-go. So here's our game plan for today. We're going to start with the core problem, then take a look at the standard tools we all use every day. After that, we'll see where those tools kind of hit a wall. And that's when we'll bring in the heavy-duty solution, Async Infra. Finally, we'll put it all together into a clear framework for knowing when to use each one. All right, first up, the core challenge. The most important thing to get your head around here is that in distributed systems, partial failure isn't some rare edge case. Nope, it's the normal, expected state of things. It's what we have to design for right from the very beginning. This slide really just lays it all out, doesn't it? On the left, you've got the warm, cozy comfort of a traditional transaction. It's a safety net, right? It's all or nothing. But on the right, well, that safety net is gone. Once your first write goes through, every single step after that is a new chance for things to fail, which could leave your whole system in a really weird, inconsistent state. So how do we deal with this? Let's talk about our first line of defense, the everyday toolkit. When we need to handle some follow-up actions or side effects, our typical go-to solution is the async task queue, or what we call ATQ. So what is ATQ really? At its heart, it's just a way for a service to give itself a task to do later. It uses Kafka under the hood to make sure that task doesn't get lost. You can kind of think of it like an async thread that's super durable. It won't die even if your server completely crashes and has to reboot. It's all about reliable fire-and-forget work. And you see this pattern everywhere. It's absolutely perfect for making your API requests feel snappier by just pushing heavy lifting into the background. It's also great for things like triggering follow-up actions. Sending an email after an order is placed. And because it's persistent, you have a guarantee that the work will eventually get done because it has retries built right in. But here's the thing. ATQ isn't a silver bullet. It has its limits. It's really designed for tasks that are pretty quick and self-contained. The moment we start talking about long-running complex jobs, well, that's when our simple toolkit starts to show its cracks. And this is the million-dollar question, isn't it? What happens when the job isn't just firing off a quick email, but it's processing thousands of records, or making hundreds of API calls, or doing some bulk update that could easily take several minutes to finish? Yeah, trying to shoehorn a long-running job into a standard ATQ handler is just asking for trouble. See, Kafka has these internal timeouts. If your handler takes too long to respond, Kafka might just assume it's dead and hand the job off to another consumer. Now your job is running twice, or it's stuck. Plus, you have no idea how far along it is, and one tiny little hiccup can bring the entire operation to a screeching halt. So to handle these big, hairy, complex jobs, we need a specialized tool. We need to bring in the heavy machinery, and that tool is called Async Infra. Async Infra is designed specifically for this exact problem. It's a whole framework for reliably running these long jobs by breaking them down into small, manageable chunks. So think of it less like posting a letter and more like sending a huge freight shipment. You get a tracking ID, you can see its progress along the way, and you get a notification when it's all done. I mean, just look at this slide. This is what you would have to build yourself to solve this problem from scratch. You'd need to manage state, handle pagination with cursors, report progress, and honestly, the hardest part is figuring out a safe way to resume if the whole thing just crashes midway through. Trust me, getting this right is incredibly complex and easy to mess up. And this, right here, brilliantly illustrates the entire value of Async Infra. It takes all of that complicated, error-prone code from the last slide, and it just handles it. It's all abstracted away. You just have to define the work you want done on a single chunk, and the framework takes care of the rest. And it pulls this off through a few really key features. State persistence means your job will survive a server restart, no problem. Progress reporting gives you and your users visibility into what's happening. Chunked processing makes sure that each little unit of work is small and fast, so you don't have to worry about those Kafka timeouts. And cursor-based iteration, well, that's the magic that lets it automatically pick up right where it left off after a failure. Okay, so now we have two really powerful async tools in our toolkit. The crucial part, obviously, is knowing which one to use and when. This framework should make that decision crystal clear. This table is basically your cheat sheet. For a simple follow-up action, yeah, ATQ is perfect. If you need to kick off a whole bunch of independent tasks, like a fan-out, ATQ is still a great fit. Just launch one task per item. But the moment you're dealing with custom bulk logic or making tons of calls to an external API, that's your signal. That's when you reach for Async Infra. So if we boil it all down to its simplest form, it's this. ATQ is for a single, short, stateless task. You fire it and you forget about it. Async Infra is for a long-running, stateful job that's made up of many, many chunks. It's designed from the ground up to be trackable and resumable. They really do solve two very different kinds of async problems. So I'll leave you with this question to chew on. Take a look at the systems you're working on right now. Are there any places where you might be using a simple tool for a really complex, long-running job? Now that you have this framework, you can see how choosing the right async tool isn't just some minor technical detail. It's absolutely key to building truly resilient systems.
Thanks for joining me.